A CPU has 5-stage pipeline where each stage takes 1 nanoseconds, 2 nanoseconds, 1.53 and 2.5 nanoseconds. Instruction fetch happens in the first stage of the pipeline. Branch instructions are not overlapped, that is, the instruction after the branch is not fetched till the branch instruction is completed. Assume that each stage requires one clock cycle. 30% of the instructions are conditional branches. Find the average execution time of the program for 1200 instructions. We need to find out the execution time of the program. So first of all, we shall find out what is the clock time period. The clock time period is set to the longest stage delay plus buffer delay. Buffer delay is not given, hence we can consider it as negligible. The clock time period is equal to the longest stage delay, which is 3 nanoseconds. Now we need to find out the execution time of the program for 1200 instructions. There are 1200 instructions. Among them, 30% are conditional branches. It means the remaining 70% are non-branch instructions. 30% of 1200 instructions means 360 instructions are branches and all branches are conditional branches. Assume each stage requires one clock cycle. So once the pipe is filled, each instruction will be processed out in one clock cycle, but because of these conditional branches, some of the instructions may require extra clock cycles to complete. And what is the extra clock cycles required for them? Here given the branch instructions are not overlapped, that is, the instruction after the branch is not fetched till the branch instruction is completed. So once a branch instruction is encountered, suppose I3 is a branch instruction, then the next instruction will be fetched only after this instruction is completed, after the fifth stage. It means an instruction following this conditional branch instruction will be processed out in 5 cycles instead of 1 clock cycle. So how many extra cycles are taken? 4 clock cycles are taken. And here the branch instructions are not overlapped. So whether the branch is taken, whether this conditional branch is taken or not, always the next instruction will be fetched after this instruction is completed. So the extra clock cycles required is equal to 4. It means all the 360 instructions need extra 4 clock cycles in addition to 1 clock cycle. So the 1200 instructions require one clock cycle to complete, and among them 360 instructions require 4 extra cycles. So once the pipe is filled, how many clock cycles are required to complete the program? 1200 plus 360 into 4, which is 2640 clock cycles. But to fill the pipe it takes some time. We get the first instruction out only in the 5th clock cycle. It means we require 4 clock cycles to fill the pipe. So to fill the pipe we need 4 clock cycles, and once the pipe is filled we need 2640 clock cycles to complete the program. So total how many clock cycles to complete the program? 2644 clock cycles, and each clock time period is 3 nanoseconds. So the total execution time is 2644 into 3 nanoseconds, which is 7932 nanoseconds.